Hey there, data geeks. Welcome back to Data Structure, where we turn data into compelling stories. I am Sudeep, and today we are uncovering a fascinating tale hidden in pizza sales data. Data analysis is basically storytelling. In this video, I'll show you how to use SQL to extract an amazing story from a pile of numbers. Whether you are new or experienced, you'll learn how to weave together four data sets using SQL joins. By the end, you'll see how data can tell a story as satisfying as a slice of pizza. Ready to uncover the story in the data? Let's dive into SQL and start a storytelling adventure. Let's start our journey by briefly exploring the four main characters of our story, which are the order details, orders, pizza types, and pizzas. The order details contains the order detail ID, order ID, pizza ID, and the quantity. The next is orders, which contains the order ID, the date when the order was made, and the time of the order. The third character is pizza types, which contains information like pizza type ID, the name, category, and the ingredients. And the fourth is pizzas, which contains information of pizza ID, pizza type ID, the size, and the price charged. Now that we have a brief understanding of the informations that the characters have to offer, let's begin our data analysis and head over to our SQL workbench. So the first step that we have to do is create a database and load the four data sets so that we can use the SQL queries to extract important information. Head over to our SQL workbench and create a database. So for our first query, we'll write create database and give a name pizza place. Let's execute this and create our database. So database pizza place has been created. Let's see if it's so. So here we have the database pizza place, but it's still empty. So we have to populate this with the four data sets that we are going to use for this analysis. So let's do that and head over to data import wizard. So first we will do is pizza types and pizza data sets, which are quite small and contains less informations. We'll import those. So because we do not yet have created the table, we'll create the new table pizza type and drop table if exist. Click on next. Check if the field types are correct. It's okay. Let's click on next and next. So it's done. We have imported our first data sets. Let's click on next and finish. Refresh this and look into the tables. Yes, we have the pizza types. Let's import the next, which is pizzas. So we'll change to pizzas and open and click on next. Create a new table with pizza's name and pizza ID will be text, pizza type ID text, size and price is double. Okay, click on next and next and next and finish. So we have imported two data sets, pizza types and pizza, and the rest two data sets we will have to import manually. Let's see how we'll do that. So first we will create a table and name it orders, in which we will have order underscore id, which is of integer nature and not null. Next we will have the order date, which is of date format and not null. Next we will have the order time, which is time data type and is also not null. And we will set a primary key, which is order ID. So it's key order ID. Let's execute this and see if the table is created or not. Okay, it's showing a successful creation. Let's see if the table is created. Yeah, orders is created. And let's populate this with data. Data import wizard, change the path to orders, open, and click on next. Order ID, order date, and order time. Click on next. Next. It will take some time to import. So our data has been imported. Let's click on next and finish this. So let's see if the data has been imported or not. Select star from orders. So the result is this: order ID, order date, and order time. So we have successfully loaded the data. Let's move on and load a final data set, which is order details. So we have to create a table, create table order details, which will consist of order detail ID, which is integer format and not null. Next, we will add order ID, which is also integer format and not null. Next, we will add pizza ID, which is in text format and not null. And lastly, quantity, which is integer format and not null. And we will define a primary key, which will be order detail ID, and next we will run this query, not null. Let's see if this gives us success. Okay, we have successfully created the table. Now let's move on and populate the table. We will change the path to order details. Click on next. Next. Check whether everything is correct. Yeah, it seems correct. Let's move on next and next. So it will take some time to import the data. So we have successfully imported the last data set. Let's click next and finish. So do a primary check whether it's loaded or not. Select star from order details. Yeah, we have it. So we have successfully loaded the 4 data sets and we are almost ready to start with our analysis. The next step is the feature engineering, and let's see how we do that. So I want to do feature engineering in the order time column specifically. Like order time is given at what time the order was placed, but I want it in a different format. For example, if the order is placed between 8 a.m. and 12, so I want SQL to show me that it's morning. Similarly, if the order is placed between 12 and 4 p.m., then it's afternoon, and so on. So let's see how we can do that. To carry out, let's move ahead and write the SQL query. So I want to select order time and use a case function. Case when order underscore time is between 8 a.m., that is 08:00:00 and 12, then I want it to show as morning. Please keep in mind that the specific timings will always be under double quotes. So morning. Similarly, I want to show that when the timing is between 12:01 and 4 p.m., then it should display afternoon. And when order time is between 4:01 and 7 p.m., then it should display evening. Else it should just display night. And end the case function and display this as time of day from orders. So let's see what the output is. Execute this, and so here we have the order time and time of day. When the time is 11:38, I think it's night. Some error. Let's check what the error is. Okay, so we have found the error. So the error is that order time will not be in single quotes, it will be a different quote, this one. So basically the single quote was throwing an error, so we will correct the order time like this. Now if we run, let's see what the output is. Okay, so now we have a correct output. It's 11:38 in the morning, so the time of day is showing morning. It's 11:57 and the time of day is morning. Similarly, after 12 it's afternoon. Then from after 4 it's evening, and the rest is night. So we have a successful query. Now let's alter the table and add a column displaying the new time of day. So we will use the alter table function. Alter table orders and add column time of day, which will be of variable character, and it will contain approximately 20 values. Let's run this. Okay, sorry, it was an error. Now it will run. So we have successfully added a column named time of day in the table named orders. Let's move on and populate the table. We will use the update function, update orders, and set time of day equal to, and next we will copy paste the case function which we have done in the last query. Okay, so let's run this and see what the output is. So we have successfully added 21,350 rows, and let's go ahead and check our orders table. Select star from orders. Let's see if the okay. So here we have that time of day column is added for each and every row. So we have successfully added the time of day column, and now let's move on to the next feature engineering. So for the next feature engineering, I want to add a month column, month name column. So I'll use the orders table, and from the order date, we will calculate the month of the order. So we will directly move on to the alter table query, where we will alter table orders and add a column month name, which will be of variable character in nature and will contain approximately 20 values and will be not null. Let's run this and see that the column is added. Now let's move on and populate this column. To populate, I will update orders and set month name equal to month name of order dot orders dot order date. Let's see if this works. This will update the month name column and add the respective month name from the orders date column. So we have successfully affected 21,350 rows, and for the final time, let's select star from orders and check the orders table. Okay, so we have added successfully the time of day and the month name. So that concludes our feature engineering for this data set. And now let's move on to the questions. So I have beforehand prepared some questions which I want to know from the data set, and let's have a look at the questions. Okay, so here are some of the questions that we will find the answers to in the SQL. So let's take care of this one by one. So the first question is, what is the total number of orders placed? Let's copy paste this to our SQL workbench and start with our data analysis. So what is the total number of orders placed? So this is a fairly simple query. We just have to add the total number of orders that were placed and display. So to find the total number of orders placed, we will just have to count the number of order ID. That will give us the total number of the orders that were placed. So to count, we will use the count function. Select count of order ID as total orders from orders table. Let's run this. Okay, so there were total of 21,350 orders placed in the data set. So it was a fairly simple query. Let's move on to the next query, which is calculate the total revenue generated from the pizza sales. So we have to calculate the total sales amount. Let's copy and paste it in our SQL workbench and find out the total revenue which was generated from the pizza sales. So before we go ahead and calculate the total revenue generated from pizza sales, we have to find out that which character or which table will give us the right answer. So let's go ahead and take a look at the four characters which of our story. So the order details contains quantity. Okay, that is helpful for us. Orders, so I don't think orders will play any role in finding out the answer to this question. Next comes the pizza types, same with the pizza types, and lastly the pizzas. So yeah, we have price. So what we can do is get quantity from the order details table and get the price from the pizzas table and find out our total revenue. So let's go ahead and write the query. So select sum of order details dot quantity and multiply it by pizzas dot price and display it as total sales. Now we have retrieved two informations, quantity from order details and price from pizzas table, but we have to do one thing before we can get the total revenue, and that is join. Now we have to join the order details table to pizzas with a common something that will give us the total revenue. So what that common something should be, let's find out. So we have order details ID, order ID, and pizzas, we have pizza type ID and pizza ID, which is, so the common link is pizza ID, which is present in both of the tables. So we will use pizza ID, and on this basis we will join both the tables. So let's go ahead and perform a join. So we will retrieve these two informations from order underscore details and join this on pizzas pizzas table on pizzas dot pizza id equal to order details dot pizza id. So basically what we have done is we have to find out one common link that joins both the tables. This is where the relational database function of the SQL comes into place. Now SQL will look into pizza ID of both the tables and join them. After joining, it will calculate the quantity, total quantity order and total price that was incurred and multiply and give us the total revenue. So our query is ready. Let's see our output. So I think there is some mistake. Let's find out what the error is. Okay, so we have found the error. It will be pizzas. So a very small error and it will throw the whole query. So let's see if we can get the total revenue now. Okay, so the total revenue is this, but it is not in the format I want. I want it rounded off to two decimals. So we will use the round function where we will round this and give it a limit of 2. So let's see if our output is okay. Okay, so the total sales is 817,860.05. So there we have it, the total sales from the pizza sales. Okay, so now let's move on to the next query. So, and the next query is calculate the average order value. So now we have to calculate the average order value of the orders placed. Let's see how we can do that. So before we write the SQL query, let's understand what the question is. We need to calculate the average order value. So as as to calculate the average order, we need to find the total order and divide it by total quantity, which will give us the average order value. So let's start writing the query. So as we need to find out the total revenue as we have already done in the previous query, let's just copy and paste this. This will be required for this query. Select sum of order quantity and price, which will give us the total revenue. And now we have to divide this by total quantity and divide it by sum of order details dot quantity. So basically that's all we need to find out the average order. So let's just put in singular brackets and save it as average order value. Okay, so we have done this, but now we have to join the two tables from which we have extracted the information. The two tables being order details and pizzas, and we have to join this on pizza ID. So we have also done that in the previous query. So let's just copy this from the previous query. So I think the query is done. Let's run this and see if there is any error. Okay, so this is the average order, but it's showing so many digits. We don't want that. Let's just round off to 2 digits. Okay, so we have done, and the average order is 16.5. So we have found out the average order. Let's move on to the next query. Let's look at our next query. The next query is identify the top 5 priced pizza. So we need to find out the top 5 priced pizza. Let's copy paste our query and let's head on and understand the question. So basically we want to find out the top 5 selling pizzas. So here we need two information, the name of the pizza and the price of the pizza. So as we need two information, obviously we need to join two tables, the pizza types which contains the name and the pizzas which contains the price. Let's go on and write the query. Select pizza types dot name and pizzas dot price from pizzas and join on pizza types on pizzas. Now we need to find a common link that joins the two tables. Let's find out which will be the common link. So in pizza type we have pizza type ID name, and in pizzas also we have pizza type ID. So pizza type ID will play a common role and help us in joining the two tables. Let's see how we can join the table. So join pizza types on pizzas dot pizza type ID equal to pizza type pizza types dot pizza type ID. Now we need to find out the top 5. So let's do an order by, and order by price in descending order, and limit it to 5 because we need only the top 5. So we have written the query. Let's see the output. Okay, so here are the top 5 pizza. The Greek pizza, which is highest price pizza of 35.95. Next we have the Greek pizza 25.5, the Brie Carré pizza, Italian vegetables pizza, and barbecue chicken pizza. We can also modify this. Suppose you need to find out the top 10 pizzas. So we will just change the limit function to top 10 and run the query. So here we have the top 10 pizzas. Okay, so we are done with this query, and let's move on to the next query. The next query is identify the most common pizza size ordered. So this, let's copy this query question and head on to our SQL workbench to find out the most common pizza size ordered. So let's understand the question. We need to find out the most common pizza size ordered. So pizza size. So where can we find the pizza size? We can find the pizza size in the pizza column. Pizza ID, pizza size ID, and pizza type ID, size, and price. So we'll use the pizza size, and we also need to find out the order quantity, which we will find out in the order details column. So we need to utilize the pizzas table and the order detail table to find out the most common pizza size order. So let's start with our query. Select pizzas dot size because we need to find out the size, and sum of order details dot quantity, and save it as total quantity ordered. And we need to find these two from pizzas and join this table with order details, and join this on pizza. Let's find the common element that will help us join the two tables. The pizza details contains order details ID, order ID, pizza ID, and quantity, and pizza contains pizza ID. So pizza ID will be the element that will help us join the two tables. Let's see how we can join the two tables. So we will join the pizzas dot pizza ID equals to order details dot pizza ID. Now we need to find the most common. Let's say we need to find out the top 5 most ordered pizza size. So let's do an order by, and as we have done an aggregate in the select column, we need to do the group by too. Group by pizzas dot size and order by total quantity ordered in the form of descending order. So we can end the query here. Let's see what we get the output. Okay, so we have an error. Let's see what the error is. Unknown column, total quantity ordered in order clause. Total quantity order, total quantity. Okay, so we have a spelling mistake. I think it will run now. I think ORDERED. Here we have a spelling mistake. I think we have made the necessary corrections. Let's see if we can get the desired output. Okay, so we have the desired output. We see that the size L, which seems to be the size large, has been ordered the most, 18,956, then followed by the medium, which is 15,635, followed by small, approximately 14.5 thousand, then XL 500, and double XL 28. So we have successfully found out the most common pizza size ordered. Okay, so let's move on to our next query. So our next query is list the top 5 most ordered pizza types along with their quantities. So we need to find out the top 5 most ordered pizza types and the quantities that they were ordered. Okay, so first let's copy paste the question and understand what we need to find out and which table will help us get the desired information. So we need to find out the top 5 most ordered pizzas. So as we to find out the top 5 most ordered pizza, we need the pizza names. So we can get the pizza name from the pizza types, and we need the quantity ordered. And can get the quantity from order details. And what will help us in joining these two is the pizza ID, as we have pizza type id, as we have pizza type id. So okay, so there is no common link between order details and pizza types. So we will also use the pizza because we have pizza id and pizza type id both in pizza table. So this will be a tricky question, but let's find out how we can write the query. So we will do a select pizza types dot name and sum of order details dot quantity. So we will get pizza names and the total quantity they were ordered. We will give this an alias, total quantity, and from. Now we have a small difficulty, which is that we don't have anything common in pizza types and order details. So order details, we have order detail id, order id, and pizza id, and pizza types we have pizza type id. But we have something in common between pizza types column and pizzas column, as well as order details column and pizzas column. So we will take help from pizzas table and join the pizza types and order details. Let's see how we can do that. So we need to find out pizza type's name and the quantity as total quantity from pizzas and join this to pizza types on pizza types dot pizzas dot pizza type id equal to pizza types dot pizza type id, and as well as join this on, and as well as we will join this to order details and join this on pizza dot pizza id pizzas dot pizza id and join this on order details dot pizza id. So we have joined successfully the three tables. Now let's do a group by, because we want to find out the top 5 most ordered pizza names. Group by pizza types dot name and order by total quantity in descending format, and as we need to find out only the top 5, we will limit to 5. So we have written our query. Let's see we can get the desired result. Okay, so here we have the top 5 pizza name and the total quantity they were ordered. The classic deluxe pizza was ordered the most of 2453, followed by the barbecue chicken pizza 2432, followed by the Hawaiian pizza, the pepperoni pizza, and the Thai chicken pizza. So these are the top 5 pizza that were the most ordered. So next, move on to our next query. The next query is join the necessary tables to find the total quantity of each pizza category ordered. Let's see how we can do that. So let's understand the question quick. We need to join the necessary tables to find the total quantity and the pizza category ordered. Let's see which character or which table gives us the pizza category. So we have the pizza category with the pizza types. The chicken classic, this is the category. We need this, and we need to find out the quantity as the total quantity ordered. So we need quantity from the order details table. Also, let's check out what the common link is. How can we join? Pizza type ID we have here, but we have only pizza ID. So basically we have to do the same thing as we did with the earlier query. We will use pizzas also to join the two tables. Let's see how we can do that. So select pizza types dot category and sum of order details dot quantity, and give it an alias total quantity, and we will extract this information from. Now the next bit is similar to the last one, so we will just copy paste, but we don't want the limit, just this one, and paste. So we have done the join function as we did in the earlier table, and I think this will work. So let's see if, okay, so we need to change one thing. We need to change this to category. So I think it's done. Let's see the output. Okay, so we have a successful execution, and the category wise total quantity ordered is displayed here. So we see that the classic category has been ordered the most, 14,888 times, followed by supreme almost 12,000 times, followed by veggie and chicken the least. So we have successfully find out the total quantity of each pizza category ordered. Okay, so let's move on to our next query. The next query is determine the distribution of orders by hours of day. So we need to find the distribution of orders according to the time of day. So let's make a slight change. This will be time of day. Okay, so let's understand the question a bit. We need to find out the distribution of orders by time of day. So we did a feature engineering with the order time column, and we found out the morning time, the afternoon time, the evening and night time. Now we need to find out the at which time how much orders were placed. So let's go ahead and start writing our query. So select, so let's start with our query. We will select, we want to find out the time of day and the total orders that were placed. So we will use time of day from the orders table. So let's select orders dot time of day and we will also find out the count of orders on that particular time of day. So we will count the order ID. So yeah, so and count of orders dot order ID as order count, and from we will select this from orders table and group by orders dot time of day and order by order count, and show it in descending order. So I think the query is done. Let's see the output. Okay, so we have a successful execution. The time of day, afternoon, we have 7,885 orders. Evening, we have 6,639 orders. Night, we have 5,584 orders. And morning, we have 1,242 orders. So as we can see that in the afternoon, we have the most orders. In the evening, we have over 6,500 orders. So we can use this data to allocate the resources like raw materials and labors accordingly. We have to look after that orders in the afternoon are the most, so we need to schedule our office workers or the workers of the counter in such a manner that we have the abundance in afternoon. So we have successfully found out the orders by time of day. Let's move on to our next query. The next query is join relevant tables to find the category wise distribution of pizza. So here also I think we can add one more question, and which will help us in understanding one more thing. I want to add the question. I want to find out that at what month we have the highest order. So we need to determine the distribution of orders by month. Let's see how which month provides us with highest order. So we have a similar query. We will just copy paste the previous one and do a couple of changes. So instead of time of day, I need month name. So let's see, we will find out the month name and count of order ID as order from and group by orders dot month name and run the query. Let's see if we get the desired result. Okay, so we have an output. We can see that the July month has seen the most order with almost 2,000 orders, followed by May 1850 orders, followed by January, August, March. Okay, so we have found out the orders distribution by month. Let's move on to our next query. The next query is join relevant tables to find the category wise distribution of pizzas. So we need to find out the category wise distribution of pizzas. So what we need to through this question, what we are expecting is the category and how much orders of each category was placed in that order. So it is a fairly simple question. We need not to do a join in this query, but let's find out which table will provide us the correct answer. So we need to find out the category. We have the category in pizza types. So we will find out the category from the pizza types and count of pizza type ID. So basically we will find out which category has how many pizza type ID. So let's write the query, select category and count of pizza type ID from pizza types and group by category. This will provide us with the category wise distribution. So in chicken category we have 6 types of pizza. In classic we have 8, in supreme we have 9, in veggie we have 9. Maybe this is the reason why chicken was ordered the least, because we have less offerings in chicken category, but supreme veggie have the highest number of pizzas available with us. So we have found out the category wise distribution of pizzas. Now let's move on to our next query, which is group the orders by date and calculate the average number of pizzas ordered per day. Okay, so we need to find out the average number of pizzas which were ordered every day. Let's see how we can do that. So let's look at the question a bit. We need to find out the average number of pizzas ordered per day, and we also have to do group by to the date. So let's see from which table we will get our answer. So it's clear that from orders we will find out the day, and from order details we will find out the quantity. But we have to join these two orders, and we will join this on, I think order ID is placed in, yeah, order ID is common in both the tables, so we will join these tables using order ID. Let's go ahead and write the query. Select orders dot order date and sum of order details dot quantity, and save this as total quantity, and from orders, and join this to order details on orders dot order id equal to order details dot order id. So we will join these two based on order id and do a group by of order date, and let's run this. So we have order date and total quantity, but we need to find the day wise distribution. So let's do a subquery and find out the day using the day function of order date as order day comma, and we also need to find out the average. So average avg of, sorry, we need to find out the average of total quantity, total quantity as average order, and we will find this from this subquery. As we have used a subquery, let's provide an alias and do a group by order day. Okay, I think we have the query. Let's see if we can get the desired result. Okay, so we have order day 1, 2, 3, 4 and the average order. So basically the order day is the first day of the month, the second day of the month, the third day of the month. Let's see which one has the which day of the month has the highest order placed. So to find that out, we will do an order by. So we will do a group by. We have done a group by. Now to find the most quantity ordered, we will do an order by, and we will order by the average order and put it in descending order. Let's see the output. Okay, so here we have the 15th day of the month has seen the highest average order of 156, followed by the first day of the month, the fourth day and the 27th day. So now if you want to find out the top 5 most ordered quantity, so we only have to do a limit to 5. Let's see the top 5 most ordered date: 15th, 1, 4th, 27th and the 31st. So these 5 days we have the most orders placed. Okay, so we have found out the average order. Now let's move on to our next query, which is determine the top 3 most ordered pizza types based on revenue. So we need to find out the top 3 most ordered pizza type based on revenue. So it's a fairly simple question. We need just to find the top 3 most ordered pizza types and base it on the revenue. So let's see from which table we can get our information. So we need the name. We have the name in pizza type. So we'll use the pizza types, and we need the quantity. We can get the quantity from order details, and we cannot join the pizza types and order details. So we'll use the pizzas to join these two tables. So let's move on and write our query. So we will select pizza types dot name and sum of, we need to find out the revenue. So to find out the revenue, we will multiply pizza dot price and order details dot quantity. Pizzas dot price and multiply it by order details dot quantity, and we will use this, and we will give this an alias as total revenue. Now we only have to, and we will extract this from pizzas and join order details on pizzas dot pizza id equal to order details dot pizza id, and join this to pizza types on pizza types dot pizza type id equal to pizzas dot pizza type id, and group by pizza types group by pizza types dot name and order by total revenue in descending order and limit to top 3. Let's see what the output is. Okay, so we have a successful execution. The Thai chicken pizza gave us the top revenue of 43,400, followed by the barbecue chicken pizza 42,700, followed by the California chicken pizza 41,400. So we have successfully found out the top 3 most ordered pizza types based on revenue. So let's move on to our next query, which is analyze the cumulative revenue generated over time. So let's find out the cumulative revenue generated over time. So to find out the cumulative revenue generated over time, so we need to find out the total revenue, which we will find out multiplying the total quantity by the total price. We will find out the total revenue, and we have to do a join. So it's a fairly simple one. Let's start with our query. First we select, and we also have to find over time. So we will uh, orders dot order time, orders dot order date, sorry, orders dot order date, and sum of, so we need to find out the revenue. We have already done that. Let's copy paste sum of pizzas dot price, or this one. So this will give us the revenue as total revenue from. Now we have to join pizzas and order details. So we have the common, I think, pizza ID. So we will use the pizza ID to join the two tables. So order details and join pizzas on order details dot pizza ID equal to pizzas dot pizza ID. We have joined, and now we will join this to the orders table, and join orders on orders dot order ID equal to order details dot order ID, and do a group by orders dot order date. So we can end the, although it's not finished, let's see what the output is. So the output is order date and total revenue. So let's find out the cumulative revenue. So we need to do a sum of the total revenue and use a subquery. Let's see how we can do that. Select order date and sum of total revenue and over and order by order date as cumulative revenue from this, and save this as A. Okay, I think we have done the cumulative revenue. Let's see the output. Okay, so the cumulative revenue is this one. Next, now on second date is this one. So let's see the difference in the cumulative revenue. What is the difference if we do the cumulative revenue? Okay, so and we have to do this. Okay, let's see the output and the difference. So if we don't use the cumulative revenue, we have the total revenue of each day. The 1st of January it's this, the 2nd of January is this. But if we use the cumulative revenue, we will find out the difference. So here is the difference. So what cumulative revenue does, it is add the previous column's revenue with the consecutive column and give us the total. So 2700 plus 2700 will give us the 5400 plus this. So it's functioning in this manner. So we have found out the cumulative revenue as and found out the answer to the question also. So let's move on to the next query. Determine the top 3 most ordered pizza types based on revenue for each pizza category. So we need to find out the 3 most ordered pizza types based on revenue for each category. Let's see how we can do that. Okay, so let's understand the question first. So we need to find out the top 3 most ordered pizza types and the revenue for each category. So in pizza types, revenue and category, we need to find 3 details. So we will get the category from the pizza types. Then we will get the name from the pizza types and the revenue from the order details and pizzas. So we need to join order details, pizza types and pizzas. We need to join 3 tables in order to find out our answer. So let's start with the query. Select pizza types dot category and pizza types dot name, and total revenue is this. Let's copy paste the here as total revenue, and from pizza types and on pizzas join on pizzas on pizza types dot pizza type id equal to pizzas dot pizza type id, and join this to order details on pizzas dot pizza id equal to order details dot pizza id. So we have joined, and let's do a group by pizza type dot category, pizza types dot category, and pizza types dot name. We will do this group by and order by total revenue. Okay, so our preliminary query is ready. Let's run and see the output. So I think there is a total revenue in order clause unknown column. So I think there is a mistake. Let's find out what the error is. Okay, so I instead of total we have to write just tot, and it will give us the right answer. Okay, so we have category, the name, and the total revenue. Now we have to find out the top three pizza types based on the revenue and each category. So we need to do a rank function, provide it some rank for every category, and then top three for every category. Let's go ahead and provide some ranks. So select category, comma, name, and total revenue, and rank over, and partition by category, because we need to find out top three most ordered pizzas of every category. Therefore we will provide a partition to the category column, partition by category, and order by total revenue in descending order, and give this an alias ranking, and extract this from this as a. So let's see how what the output of this query is. So here we have added a column ranking, and in the chicken we have 1 2 3 4 5 6 ranks. In the classic we have 6 7 8 ranks. In the supreme we have 9 ranks. In the veggies we have 9 ranks. Okay, so but we need only the top 3 ranks of each category. So let's do that. Select star from this and save it as B, where ranking is less than equal to 3. So I think it's done. Let's run this and see the output. Okay, so we have a favorable output. The category chicken, the top three ranks are the Thai chicken pizza, the barbecue chicken pizza, and the California chicken pizza. The classic category, we have the classic deluxe pizza at rank 1, the Hawaiian pizza at rank 2, and the pepperoni pizza at rank 3. Then comes the supreme, the spicy Italian pizza, rank 1. Rank 2 is Italian supreme pizza, and the Sicilian pizza at rank 3. Similarly, for veggie, the 4 cheese pizza comes first, the Mexican pizza comes second, and the 5 cheese pizzas comes at the third rank. Okay, so we have found the correct answer we were looking for. So we have to use two subqueries and a rank function to find the answer. Let's move on to our next query and the next question, which is our final question, which is calculate the percentage contribution of each pizza category to total revenue. Let's find out the percentage contribution of each pizza category to the total revenue. So let's understand this question. We want to find out the total revenue and what percentage is each pizza contributing to. Let's go ahead and let's see where we can get this detail. We can get this detail from, we can get the total revenue from pizza and order details, and we want to find out the percentage contribution also. So let's go ahead and okay, so we need to find the category also, which we will find the from the pizza types, and we will join this using the pizza type id and the pizza id. Okay, so let's go on and write our query. So select pizza types dot category and we need the revenue. We have already found out the revenue. We will just copy paste the revenue from here. The revenue, we want to find the pizza type category and the total revenue, and we want this from pizza underscore types and join. So we have already done this. Let's just copy paste from here. Okay, so we have copied the join function from the previous query and pasted it. So let's move on and write our next query, which is group by pizza types dot category, and let's run this and see what our output is. Okay, so we have category and total revenue of each category, but we need to find out the contribution of each category to total revenue. So what we will do is write another subquery and find out the total contribution. So now let's move on to find the percentage contribution. To find the percentage contribution, we will select sum of order details dot quantity multiply by pizzas dot price, and because we know we want to round off to nearest two decimals, round comma 2, and save it as total sales from. We already have done this. Let's copy paste order id dot pizza id and multiply it by 100 comma 2 as percentage contribution, and select this from given alias. And I think there is some error. Let's find out what the error is. Select round sum, sorry, select round sum of order quantity into pizza price, comma, round off to 2 as total sales from. Okay, so we have written the query, and just write another sub query to select category and round of total revenue divided by select. So we will have to add another bracket here, and we have a successful query. It's showing no error. Let's find out if it works. And the okay, so output is this. So basically we have found out the percentage contribution of every category to the total sales. We have seen that the classic category is contributing the most percentage to the total sales of 20, almost 27%, followed by the veggie category, which is almost 24%, followed by supreme 25%, and chicken we have 23%. So through the data analysis, we have seen that chicken, we have the least contribution to the sales and the least offerings also we have in the category of chicken. So it's justifiable that chicken is contributing to the least. So we have found out our questions answer to all the questions that we were set out to explore, and all that all that is left is form this in a presentable manner. So I hope you like the video, and through this video I've tried to show you some feature engineering of how to change the order time to the time of day, and change the find out the month name from the order date. And then we moved on to find out some of the answer to our questions, which will help us in building up our story, and help us in understanding what's going on with the pizza sales. So I hope you like the video. If and Please don't forget to give a thumbs up if you liked the content, and your comments are always welcome. Please do comment, and if you have any other question you want to add to this question list, please write it in the comment. And thank you for watching the video.